Hello, welcome everyone, welcome back to my channel. As I have already told you that I have started series on TMUA and we have already done the part 1 in which I have already explained the 5 question of 2023 paper 1, and in this section I'll be doing the next 5 questions. So let me start with it. We know this will be solved by binomial expansion, and the generalized theorem for binomial is NCR a to the power of n minus r and b to the power of r sigma r is equals to 0 to r is equals to n. That means one by one we have to put n is equals to 0, 1, 2, 3 till 12. So clearly we have to find the number of terms. If I ask like what will be the total number of terms, so first I'll start with putting n is equals to 0. So when I put n is equals to 0, 1, 2, 3 till 12. So obviously the total number of terms are 30. Out of these 13 terms, we have to find how many terms are not divisible by 12. If a number is divisible by 12, it has to be a multiple of 4 and a multiple of 3. In this case, a is 2, that means 2 to the power of n minus r, and b is 3x to the power of r. That means r has to be a non-zero in that case, because that will make it only the multiple of 2 at that time. Also, this one also has to be non-zero, because if this will become 0, then it will become purely divisible by 3. So in that case I have to find those terms that will give me non-zero. That means clearly r should not be equals to 0, and this can become non-zero when r should not be equals to n. So that means n minus r should not be equals to 0, so n should not be equals to r. So these are the two terms. R should not be equals to 0 and r should not be equals to n, and n is 12 here. So I need to check these two only. So let me substitute 0 here. So 12c 0, 2 to the power of 12 and 3x to the power of 0. That will give me 1, 2 to the power of 12 only. Obviously this is not a multiple of 12, so cancel this out. Other than that, last one. So last one is, let me put 12 here. 12c 12, a to the power of 12 minus 12 0, and b to the power of 12. This will give me 1, 1, so 3 to the power of 12. This is not a multiple of 12, obviously. Also, one more case is there where we can find a not factor of 12. Where? Because we know this one. We know this is the format. So obviously, except for when 3x to the power of 0 is there, always we'll get 3. If I'm putting 1, 2 or 12, any number in between, always this number will be a multiple of 3. And for this one, except for 2 to the power of 0, all the numbers will give me the multiple of 2 but not the multiple of 4. For 0 and 1, if I'll exclude, from 2 to 12, if I'll put 2, 3, 4, 2 to the power of 5, to the power of 6, it will always be a multiple of 4. But when this will be like 2 to the power of 1 is there, then it will not be a multiple of 4. So that's the third case where we can expect to find not a multiple of 4, because in that case it will be just 2 only. So that means I have to put n minus r is equals to 1, which means r is equals to 11, because n is 12, so r is 11. So that means when I put 12c11 times 2 to the power of 12 minus 11 and 3x to the power of 11. So in that case, this will give me the multiple of 3, obviously. This will give me 2, so That means this is not a multiple of 12, but let me solve this one. So 12C1 is actually 12. But since 12C1 11 is a multiple of 12, that means in the case of r equals 11 also we'll get the multiple of 12. So there are only two cases where can I expect not to get the multiple of 12, or we can say where the coefficient is not divisible by 12. So in short, we can say there are such 11 where we can find the coefficient p divisible by 12. Px and Qx are defined as follows. Px is equals to 2 to the power of x plus 4 and Qx is 2 to the power of 2x minus 2 minus 2 to the power of x plus 2 per 16 plus find the largest value of x such that p of x and q of x are in ratio 4:1. This is very simple. So it's simple. We have to start with the ratio which is already mentioned and put the value of p of x, which is 2 to the power of x plus 4, and this one is 2 to the power of 2x minus 2 minus 2 to the power of x plus 2 plus 16 is equals to 4/1. Now let me cross multiply. It will go up there, it will go up there. So it will become 2 to the power of x plus 4, and this will be 4 times 2 to the power of 2x minus 2 minus 2 to the power of x plus 2 plus 16. Now further, this will be 2 to the power of x plus 4. This will be 4 times 2 to the power of 2x over 2 to the power of 2. I have applied the rule a to the power of m over a to the power of n. This one, basic indices rule, and it's a to the power of m minus n. So either we can go like this or we can move in a reverse way as well. So this can be written as this one clearly, minus 4 times 2 to the power of 2x times 2 to the power of 2 plus 16. Clearly, I can write 2 to the power of x as y, and squaring both the sides will give me 2 to the power of 2x whole squared is equals to y squared. So this will give me 2 to the power of x is clearly what? Y squared, because we know e to the power of m whole to the power of n is e to the power of mn. So that means 2 to the power of 2x is equals to y squared. So this is y plus 4. This is 4 times, this will give me y squared over 4 minus 16 times y plus 16. Now this will be y plus 4 is equals to y squared minus 16y plus 16. Bringing all to the one side, this will give me y squared minus 17y plus 12. Oh, I'm really sorry. I forgot to multiply with 4. So that means this will be 64 minus 4, that is 60. Now the product is 60, sum is minus 17, it's minus 12 and minus 5 be the two factors. So that means y minus 5 times y minus 12 is equals to 0. From here, y is equals to 5, y is equals to 12. Y is 2 to the power of x. So 2 to the power of x is equals to 5, or 2 to the power of x is equals to 12. In order to find the value, take the log to both the sides. It will give me log 2 to the power of log base e, or ln 2 to the power of x is equals to log 5, or bring out x here. So x log base e2 is equals to log base e5, or x is equals to log base e5 over 2, that is log base 2 5. This can be written, if you know the rules of log, this is how you can write. If I see that one, I can see as in option E. Another one would be taking log to both the sides. So x log base E2 is equals to log base E12. X is equals to log base E12 over log base E2. So that will give me log base 212. Now you can clearly see two are matching, E is matching and F is matching. But what's written here? Find the largest value. Well, even I can clearly see on right hand side 12 is the larger one, so I have to pick this one itself. But still better is find both the values and see. Even you can clearly see they are having the same base. The number is greater. That means obviously the larger one is going to be F. Now question 8 says a triangle XYZ is called fun and it has the following properties. Angle YXZ is 30 degrees, XY is root 3A, YZ is A, where A is a constant. For a given value of A, there are two distinct fun triangles S and T, where the area of S is greater than the area of T. Find the ratio area of S to the area of T. Okay, so let me just quickly draw a triangle like this. And let me name it X, Y, Z. So angle YXZ, that means this angle, is given as 30 degrees. XY is root 3A. YZ is A, where A is constant. And there are two other distinct fun triangles having the different values of A, like for a given value of A basically. And we have to calculate the ratio and specifically mention that the area of S is greater than T. So I think by finding X that it can help us in finding, because they are asking you to calculate the area, and how area we can find. It's half AB sine C. That means half times multiplication of two sides and an included angle. Unfortunately 30 degrees is not an included angle. There is no other way by which we can calculate the other angles, but I think XZ is much more easier to calculate by using the cosine rule. So applying cosine rule, let's say this be X. So obviously if we are aware of this angle, I'll start with the opposite side, which is A. A squared is equals to sum of squares of other two sides. So root 3 squared plus X squared minus 2 times root 3A times X cos of 30. This is A squared is equals to 3A squared plus X squared minus 2 root 3 AX. Cos of 30 is root 3 by 2. This is A squared is equals to 3A squared plus X squared minus 2 will cancel out. This will be 3AX. So here this will be, finally let me bring all of that on one side. So this will be 3A squared minus A squared is 2A squared X squared minus 3AX plus 2A squared is equals to 0. This is an equation in X. We have to find the value of X because that's what we are finding. We are finding the value of XZ. So applying formula method, minus B plus minus root B squared minus 4AC, which is 8 squared over 2. Root of A squared is A, so 3A plus A by 2 and 3A minus A by 2. It will give me two different values of XZ. One is 2A and another is A. So obviously for the same value of A, I have two different triangles. In one case, my value is A. So in that case, my triangle, the area of the triangle will be half times root 3A times A times sine 30, which is root 3A squared by 4. And now substituting 2A, it will be half times root 3A times 2A sine 30, which is root 3A squared by 2. Clearly it's mentioned that the area of S is greater than the area of T. That means this is the area of S and this is the area of T. And when we'll divide it, which is root 3a squared by 2 over root 3a squared by 4, it will give me 2:1, which is B. Moving on to the question number 9. How many solutions are there to 1 plus 3 cos theta whole squared is equals to 4 in the interval 0 to 180 degrees? So we just have to expand this, which is 1 plus 9 cos squared 3 theta plus 6 cos 3 theta is equals to 4, or 9 cos squared 3 theta plus 6 cos 3 theta minus 3 is equals to 0. Divide both the sides by 3 will give me 3 cos squared 3 theta plus 2 cos 3 theta minus 1 is equals to 0. It's easy if I'll convert cos 3 theta to y. Will give me 3y squared plus 2y minus 1 equals 0. On factorizing, the product has to be minus 3, sum is 2, that means two numbers are 3 and negative 1. So this will be 3y squared plus 3y minus y minus 1 equals 0. Taking 3y out as common, this will give me y plus 1, and here minus 1 out is common, y plus 1. So two factors are 3y minus 1 times y plus 1 equals 0. That means y1 is 1 by 3 and y2 is negative 1. Because we have substituted the value of y as cos 3 theta, so that means cos 3 theta is equals to 1 over 3, or cos 3 theta is equals to negative 1. And now is the time to apply cos rule, which means I have to draw this one and cost. That means here cosine and sec, cos and sec are positive. Here all the trigonometric functions are positive. Here sine and we can say its inverse cosec is positive, and here tan and cot are positive. So first we have to take the inverse of this one. That means 3 theta is equals to cos inverse 1 by 3. And cos inverse 1 by 3 is 70.53. So 3 theta is 70.53. Don't solve theta right here. This is not the correct. Why? Because we have to find, it says theta should be in between 0 to 180 degrees, but we are calculating 3 theta. So that means multiply all the sides by 3. This will give me 3 theta and this will be 540 degrees. That means we have to calculate all the values that are between 0 and 540. We have calculated the inverse of 3 theta is 70.53. So here I'll be drawing 70.53, somewhat like this. This is. So symmetrically, I'll draw in that place where I can find the cosine, because we have taken the inverse of cosine be positive. Right, 1 over 3 is a positive value. So positive, as I mentioned, it's the fourth quadrant and the first quadrant where I can find the cosine positive. So which means symmetrically I have to draw this one, which means this part represents 70.53 and similarly 70.53. So one value is clearly 70.53. This value is definitely 360 minus 70.53, which is 289.47. 289.47. The next is, again, these two are the fixed ones that I'll get. But the next is after 360. I have completed this and then again I'll start moving the second round. That means 360 plus 70.53, which is 430.53. And this is definitely, again, if I'll moving, this is already 360. So this whole plus 289.47 after 360 will give me the answer, or 720 minus 70.53 will give me, it's just the second round that I'm doing. So 249.47. Obviously, this 3 theta has to be in between 0 to 540. So this 649 we don't have to include. These three angles are there. So the value of cos 3 theta, where it's 1 over 3, these three are the angles. Now we have to use this one. Cos 3 theta is equals to -1. Now for 3 theta, it has to be cos inverse -1, which is 180 degrees. Again, between 0 to 180, theta has to be between 0 to 180. That means 3 theta, multiply all the sides by it. So that means 3 theta should be between 0 to 540. So we have to find all the angles that are between 0 to 540, because we know that the 3 theta is 180 degrees and we know cosine is -1. That means the negative quadrants are second and third. So in this quadrant and in this quadrant, we can expect the cosine to be negative, and it's lying here 180 degrees. So that's the only one value shared by each actually. So that's a symmetrical. If I'll draw, that's the only thing. So that means 180, and then again I have to move all the way 360 to get the next angle. So 360 plus 180, which is 540. So two angles for which cosine 3 theta is -1 is 180 degree and 540 degrees. So there are, you can clearly see 5 total values for this one, and hence E is the correct answer. Moving on to the last question. This is not the last question of this paper, but the last question of this section, because there are 20 questions. 10 questions I'm doing in this video, and in the next video I'll be doing the next 10 questions. You can clearly see these questions will give you a better idea that what all topics we have to go through. So obviously after completing this paper, we will be doing one topic. So as I told you, you have to do these past papers 2-3 times, the mock papers that I'm going to provide 2-3 times, and the quick revision, the topics that we'll be doing. So these are important as well, because if you don't know the concepts, you're not able to pull out these questions obviously. So this is the last question, and once we complete the paper, we will be doing the questions topic wise. So in that case, after this paper, my first topic is going to be integration. After completing that, again we'll be moving on to the past paper questions. So moving on to the last question. The trapezium rule with 4 stripes is used to estimate the integral from -2 to 2 root of 4 minus x squared dx. What is the positive difference between the estimated and the exact value of the integral? So obviously for the estimation, we have to use the trapezium rule, whereas for the exact value, we have to use the integration. And here, this exact value can also be calculated by 2 ways. First is by the circle one we can easily calculate, and the second one is actually the method of integration. So let me explain you, because this is y is equals to root of 4 minus x squared. So if I square both the sides, it will give me y squared is equals to 4 minus x squared, or let me take it x squared onto the left hand side. It will give me x squared plus y squared equals 4, which clearly gives me the equation of a circle with center 0, 0 and radius 2. So when I plot it on the graph, it would look like this. This is the center 0, 0. This is -2, +2, +2, -2, and circle would be inside it. Obviously the one that I'm going to draw is not a perfect one, but we can understand that these are actually the endpoints, like this. It's mentioned that we have to integrate it from -2 to +2. That means it will start from here, this end. -2 is the end of this, and +2 is the end of this, actually, like this. And because here the equation of a circle has the root, if you can clearly see the square root is involved, that means the resulting graph is just the upper semicircle above the x-axis. So this area, because we know integral is what? The area under curve. So this area will give you the value of the exact integral. Obviously, the area of the circle is pi r squared with the radius 2, that means 4 pi. But since this question involves the area of the semicircle, it's going to be 2 pi. That's the first way of calculating the exact value. The second way is algebraically, like the method that we use to calculate the integration. It's comparatively a linear. This is the substitution of the trigonometric functions. So it's minus 2 to 2 root of 4 minus x squared dx. And for any type of such questions, we always use this one, substituting the trigonometric function. I can clearly see that I can substitute x as 2 sine theta or 2 cos theta, anything will work. Since I have substituted x, so obviously we have to replace this one. So dx, that means the differentiation. So differentiation of this is going to be 2 cos theta. Now, obviously this limit is for x and we have converted into sine theta, so limits will change obviously. So minus 2, in place of x I'll sub in the value minus 2 sine theta. That means negative 1 is equals to sine theta, and on taking the inverse, because now everything has been converted to theta, so limits will also be converted into theta. Sine inverse negative 1 will give me negative 90. Then similarly to sine theta, so sine theta is 1. Taking inverse, I'll get answer as 90. So now we have to replace everything. So 4 minus 2 sine theta whole squared root, and dx is 2 cos theta, and integration minus 2 is minus 90 plus 2 is 90. 4 minus 4 sine squared theta, that means 4 take out as common, 1 minus sine squared theta times 2 cos theta, from 90, negative 90 to positive 90. 1 minus sine squared theta is cos squared theta. So 4 cos squared theta and root of it is 2 cos theta. So 2 cos theta times 2 cos theta, and integration from 90 to 90, and it's d theta. Here also it has to be the d theta. This will give you 4 cos squared theta d theta from minus 90 to 90. Obviously, I can't integrate directly cos squared theta, but there is identity, a trigonometric identity, which is cos 2 theta is equals to 2 cos squared theta minus 1. This will help me in finding, or first of all, replacing cos squared theta in terms of cos 2 theta. Cos 2 theta plus 1 over 2 is equals to cos squared theta if I'll make cos squared theta as subject. So I can replace cos squared theta with cos 2 theta plus 1 over 2 d theta. Cancel it out. Remaining is 2 times integration from negative 90 to positive 90 cos 2 theta plus 1 d theta. Obviously, if you have limit from negative a to positive a, if the whole function is odd, directly the answer would be 0, and if the function is even, the 2 will come out as common. This is an even function. Or even if you don't know about the even or odd function, we can directly calculate the value. So now we just have to integrate, which will give me sine 2 theta over 2 plus theta from minus 90 to positive 90 2 times. Now when I substitute the upper limit here, it will become sine 180, which is 0. So 90 minus lower limit. So again, if I put minus 90 here, sine minus 180 will give me 0 again, and this will be minus 90. It will be 2 times. So 2 times 90 plus 90, 180, which is 360, or we can say in terms of pi, it would be 2 pi. This is the exact value that we have calculated earlier as well, taking the example of a circle. We have to use the trapezium rule to get the value of like the approximated one. So the estimation would be, let me delete some of its part. So the formula to calculate is, the trapezium rule is half times h y0 plus yn plus 2 times y1 till yn minus 1. This one. Obviously, they have specifically mentioned that with the stripes of 4, that means h is 1. From -2 to +2, the stripes of 4 is what? -2, -1, 0, 1, 2. That's how we'll divide it. That's the width basically. So I'll make a table. It's -2, -1, 0, 1, and 2. And let me put the values one by one. So when I substitute the value as -2 in this given equation, which is root of 4 minus x squared, it will give me obviously 0. When I put -1 here, this will give me root of 3. On putting 0, I'll get 2. On putting 1, I'll get root 3. And on putting 2, I'll get 0 again. So put the values. Half times 1, y0 is 0, plus yn is 0, plus 2 times root 3 plus 2 plus root 3. So that will give me half times 2 plus 2 root 3, or 2 plus 2 root 3 is the answer. So we have to find the positive difference. So just let me subtract. So 2 plus 2 root 3 minus 2 pi. And if I simplify it, so I can easily understand that 2 pi is the bigger one and 2 plus 2 root 3 the smaller one, because we want to calculate the positive difference. So let me write 2 pi minus 2 plus 2 root 3, and which then can be simplified as, if I take out 2 out as common, pi minus 1 minus root 3, which matches with option B. And that's your correct answer. So that's it for today. In the next video, we'll be doing the remaining questions. And also, if you're looking for one-on-one classes for TMUA, it's just £13 per hour. So you can book your free demo, and all you need to do is just email at exactacademy@gmail.com. So that's it for today. Bye. Take care.